So let's talk about independent matrix. So a matrix is defined as independent if at all the square matrix remains unchanged. So what do we mean? If you have got matrix A, you square matrix A and the results remains the same as A. So remember, let's say we have got A transpose, then on top we have got A transpose. This becomes A. But in this case it's different. Now we're talking about squaring the matrix. So if you square the matrix and you get the same, it doesn't change. So we multiply A times A, okay, and if we multiply A times A, the result doesn't change, then that matrix is independent. It's said to be independent. Okay, so what do we mean? So the question is, a matrix A is said to be independent if A squared is equal to A. Show that matrix A is independent. So we need just to multiply A times A, because A times A is A squared. So if A squared, the answer we are going to get should be exactly as A, then we have shown that this matrix is actually independent. Okay, so the square matrix, it remains unchanged, then that matrix we is said to be what? Idempotent matrix. Okay, so let's go ahead and do that. So A squared is 2 neg 1 1 neg 2 3 neg 2 neg 4 4 neg 3. So we are multiplying this by itself. So I think the best way I would have put it on top there. Okay, it's fine. So we have 2 again, neg 1 1 2, which is negative, then 3 negative 2 negative 4 4 negative 3. There we go. So we'll say A squared will be equal to, so we have got row by column. We are multiplying it, rows by column. So 2 times 2 is 2, plus negative 2 times negative 1 is 2, negative 4 times 4, that is negative 4, negative 4 times 1 is negative 4. Done. So I'm done with this and that. Now I need to go to the next part. So it's this part and the next part. That's how we multiply. So it's 2 times negative 2 is negative 4, negative 2 times positive 3, that is negative 6, then negative 4 times negative 2, that is positive 8. Now I'm done with this part and that part. Now I'm remaining with this part and this part. Okay, so it is 2 times negative 4, that is negative 8, then negative 2 times 4, that is again negative 8, then negative 4 times negative 3, that is positive 12. So we are done with that part. Okay, next is this one with this first, then we'll go to that, we'll go to that, just like that. So we have negative 1 times negative 2, negative 1 times negative 1, sorry, that is positive 1. Then positive 3 times positive 3, that is 9. 4 times 4, what are we saying? This is not right. So it is row by column. So negative 1 is that like this, negative 1 times this. So negative 1 times 2, that is negative 2, plus then 3 times negative 1, that is negative 3, plus 4 times 1 is 4, then again the same one times that. So negative 1 times 2, that becomes positive 2, 3 times 3, that becomes 9, then 4 times negative 2, that becomes minus 8, then again the same one and this one. So negative 1 times negative 4, that is 4. 3 times 4, that is 12. Then 4 times 3, that should give me negative 12. Okay, next is this one by that one. So now we have 1 times 12 or 2, that is 2. Then negative 1 times negative 2 times negative 1, that is positive 2. Negative 3 times that, negative 3. Then 1 times negative 2, that is negative 2. Negative 2 times that, negative 3. I'm multiplying with this part. Then 3 times this is negative positive what? Positive 6. Yeah. Then again this and the last one. 1 times negative 4, negative 4. Negative 2 times 8 or 4 is negative 8. Then 3 and that one plus 9. So meaning a squared will be equal to, so let's first add them. So 2. So here I can clearly see that I have already made a mistake, because look, we are saying this part here, 2 plus 2 is 4, minus that is going to give me 0, but it's supposed to give me 2. So meaning that I made a mistake here when I was multiplying. So I multiplied this 2 times 2 is 4, but I had to put 2 here because it's this by that. So this was supposed to be 4. Okay, so that this and this is 6, then 6 minus 4 is 2. Now it's making sense. Let's go to this, the second one. So this and this is negative 10. Negative 10 plus 8 is negative 2. That's okay, because I have negative 2 there. So the best part with the idempotent matrix, you'll be able to know that you have made a mistake because it's supposed to come exactly as A. Then now here we have, this is going to give us negative 16. So negative 16 plus 12. So 12, 13, 14, 15, 16. That is negative 4. That's okay. Done. Now let's look at this. This is going to give me negative 5. Negative 5 plus 4, negative 1. That's okay. This one, 11. So 11 minus 8, that is 3. Then 4, we have got 12. 12 minus that is 0, so we have 4. Then here we have 4 minus 3, that is 1. Then here we have got negative 8 plus 6, negative 2. Then negative 12 plus 9, that is negative 3. So look at this. A squared is exactly, so A squared is exactly as A, hence shown. So this is how you show that this matrix is idempotent. So idempotent matrix, just know that when you square the same matrix, the matrix remains unchanged. It's going to be the same. So that matrix is said to be idempotent. Now go ahead and look different questions, try to prove them, try to show them that they're idempotent, and then see if at all you're okay. So remember, if you want to access more videos for matrices and also other topics from math, a lot of topics that they can help you to go far, just go on Google and type Transcended Institute. You'll be able to go back to, it's going to take you to the website. Then that website has got all the topics and all the courses for natural sciences. Not only that, but if you want to go direct, you can just check the link in the description. You'll be able to see the link for our website. Then you'll be able to go there and access our videos. Okay,